In this video, we're going to talk about solving systems of equations using something called a determinant. So before we talk about what a determinant is, you need to know where it comes from. So a determinant is a number that comes from doing some arithmetic to something called a matrix. So a matrix is just a way to express a set of numbers. And it looks something like this. It has these brackets around it. It can be used for solving equations. It can represent just any array of numbers. So a determinant can only exist when you have a square matrix. So the number of your rows equals the number of your columns. So you can have a 2 by 2, 3 by 3, etc. So we're going to talk about the determinant of a 2 by 2 in this video. So the way that you go about finding a determinant is you start with a linear system. So let's say I have these two equations here. So that's going to have two coefficients each, AB and CD. Now I can create a coefficient matrix from these numbers and arrange them like so. And the way that you find the determinant of that coefficient matrix is you multiply A times D, so you cross down, and then you also multiply C times B, and you cross up or down depending on which way you like to look at it, and you subtract BC from AD. The cool thing about a determinant is that if you calculate it to be any non-zero number, that tells you that that system has exactly one solution. So let's take a look at this example. Now notice before we start that it looks slightly different than a matrix. So a matrix has these brackets and a determinant just has these straight lines here. So that's how I know I'm finding a determinant. Now I'm going to multiply down, so that's 3 times 1, and then I'm also going to multiply up, and I'm going to subtract the 6 times the negative 2. So if I simplify my arithmetic, I find that the determinant, or a capital D, equals 15 for that coefficient matrix. So something even cooler than a determinant, if you can believe it, is something called Cramer's rule, which works for square matrices, so our 2 by 2, 3 by 3, etc. So for a 2 by 2, the Cramer's rule actually tells you, if you follow all of its instructions, it can give you the values of x and y, or whatever solves your system of equations, using the determinant. So you can use substitution, elimination, you can graph for a solution to your system, or you can use Cramer's rule using matrices and the determinant. So there's a couple of basics to this, and once you master them, you can use Cramer's rule for any 2 by 2. So number one, you start with a linear system with your A1, B1, A2, B2 being your coefficients. So that's going to make up your coefficient matrix. Now there's something called an X matrix and a Y matrix, and that comes from your coefficient matrix. And instead of writing your X coefficients, you write your constants there. So you just replace the X's with the solutions, or the constants at the end. Same thing with the Y. Instead of writing the Y's, you'd write the constants. And of course, you can always find the determinant from each of these matrices. So in order to solve for the X variable, you take the X matrix, whatever that determinant equals, and you divide it by the coefficient matrix determinant. And then for the Y, you do the same thing, but for the Y matrix, and then you put that over the coefficient matrix down here, and that should give you your X variable and your Y variable. So the only situation where Cramer's rule does not apply is when the coefficient determinant is 0. So remember, the determinant will determine if you have a system with one solution when there is a non-zero result as the determinant. So if it's 0, then that's going to mean that it either has infinite solutions or it has no solution. So just be careful of that. All right, let's take a look at this example. So I have a system of linear equations here. I need to solve for an x and a y variable. So I'm going to use Cramer's rule for this. And what I know is I need to have a coefficient matrix, which I'm going to find the determinant of. And I'm also going to find the determinant of the x and the y matrices. So this is going to be my determinant of my coefficient matrix. Now I'm going to do 3 times 1, that's 3, and then I'm going to subtract my 6 times negative 2, that's negative 12. I subtract it, it gets added, that's the word, and I get 15 there. So now it's time to find the determinant of my X matrix. So remember, I just replace these two numbers with these two numbers, and I'm going to do the same thing here to find the determinant. 4 times 1 is 4, and then I'm going to subtract 13 times negative 2. It's going to end up being 26, so that's 30. And I'm going to repeat the same process to find the determinant of Y, but instead of writing my Y values that I have here, I'm going to replace them with these numbers just as I did right here. So let's calculate that determinant. So the determinant of my Y matrix is 15. So now what I do using Cramer's rule is I take my determinant of X value and divide it by the coefficient determinant. So that would be 30 divided by 15, and that's 2. And then I take my Y, which is 15, and divide it by that 15, and I get 1. So the solution to my system is going to be 2, 1. Now, of course, I could check that with substitution, elimination. I could graph these two things. I could plug them, the 2 and the 1, back into the equations to check for that, and I should end up with the same thing. So those are all very different ways to get to the same place. And that's going to do it for this video. Thanks for watching.